Okay, in this video we're going to be doing Calc AB problem set number 130. The problems and a playlist are in the description below. Let's see what we're doing. Number 1, given the function f of x equals the square root of 49 minus x squared, which is a semicircle. I don't know if that's going to be relevant, for negative 7 to 7. Write the equation of the line tangent to 1 over f of x at x equals 5. Okay, so we need the value of our new function. We need the value of 1 over f of 5. So 1 over f of 5 is going to be 1 over, I did not pick good numbers here, radical 24, that's the best we can do. And then we also need the derivative of 1 over f of x. I'm going to write that as f of x to the negative first so that I can just like chain rule this thing. So that's going to be negative f of x to the negative second times f prime of x. Now we just got to plug in and get this hopefully right. So we'll have negative f of x to the negative second times 1/2 the quantity 49 minus x squared to the negative 1/2 times negative 2x, because we need to actually find f prime of x. And now we're evaluating at 5. When I did that, I got negative quantity root 24 to the negative second times negative 5 over root 24. I'm pretty sure that's right. And then that simplifies not much into 5 over 24 root 24. So the tangent line, it's kind of gross. Y minus 1 over root 24 equals 5 over 24 root 24 times a quantity x minus 5. All right, that is a weird problem. I mean, it's straightforward, but like all the numbers are kind of disgusting. I wonder what I meant to do in this problem, because the numbers on the next part are going to be gross too. I'm going to actually go to a new page for part B. We want to find b so that the function g of x shown below is continuous. So continuity at a point means the limit exists, the function exists. For the limit to exist, we need limit from the left equal limit from the right. I'm going to look at the limit from the left and the right. So starting with the limit as x approaches 3 from the left of g of x. When you're to the left of 3, you're on negative 7 to 3, so f of x plus 2. And then this, if we plug 3 in, we get root 49 minus 9 is root 40, and then just plus 2. I don't know. That's the value. All right, we got to take the limit as x approaches 3 from the right of g of x. When you're to the right of 3, you're between 3 and 7, so 4x plus b. And we can just sub in 3, so we're going to get 12 plus b. So for this thing to be continuous, we need the limit from the left equal limit from the right. So we need this to be true. And then we just solve for b. So b is root 40 minus 10. And then I like to write a statement that shows that like I've actually done what I set out to do. So I'm going to say, if b is root 40 minus 10, then the limit from the left equals the limit from the right equals the value of the function, and therefore g of x is continuous at x equals 3. And that's it. All right, let's look at the next part. Evaluate the integral from negative 7 to 0 of x f of x dx. So let's just write it. Let's sub in f of x. So it's x root 49 minus x squared. The radical kind of disappeared up there. I'm not sure what that's about. So this, if you look at it, let u equal 49 minus x squared, du is negative 2x dx. So there should be a negative 2 on the inside. Balance it with a negative 1/2 on the outside. And now this is perfect. So we'll get negative 1/2 and then plus 1 times the reciprocal. So it's the exponent will be 3/2. So 2/3. The quantity 49 minus x squared to the 3/2. And then we are going from negative 7 to 0. When we plug in 0, so this is negative 1/3 because negative 1/2 and 2/3. So negative 1/3, we will get the 49 to the 3/2, which I mean, I think you could probably leave, but when you plug in negative 7, you actually just get 0, which is nice. And then 49, the square root of 49 is 7, and then 7 cubed. So it's negative 1/3 times 7 cubed. 7 cubed is 343, so this is negative 343 all over 3. That's your final answer. All right, there's one more problem in this problem set. Let's take a look. Whoops, what is this nonsense? Okay, evaluate the limit as h approaches 0. Sine squared of 5, the quantity x plus h, minus sine squared of 5x all over h. All right, you see the limit as h approaches 0, you instantly think derivative. If this is the derivative, it's going to be limit as h approaches 0, f of x plus h minus f of x all over h. F of x is going to be sine squared of 5x. So we just need to find the derivative of sine squared of 5x. This is pretty straightforward. This is a chain rule problem, so it's going to be 2 times sine of 5x times the derivative of sine of 5x, which is going to be cosine of 5x times 5. And so our answer here for f prime is 10 sine 5x cosine 5x. So I think we should probably put that up there. That's what the limit is equal to. Also, because 2 sine a cosine a is the sine of 2 times a, we can say it's 5 times 2 sine a cosine a. So it's 5 times sine of 2 times 5 10x. So another option is this. You're not going to run into that in Calc AB, but it's a really good idea to know that because in a lot of other applications you will see it. All right, that's the end of this problem set. I hope this was helpful, and good luck.